All right, guys. Let's see. So connecting our our USB to our microcontroller with Servo Man assembled. Um, just I go straight through the top, from the top of the head, in between all the LED leads, and I go right to that micro USB connector on the Raspberry Pi Pico. You can use a pencil or, kind of like I mentioned in the wiring video, some long needle nose tweezers to kind of bend the pins out of the way. Try to make sure the LED leads do not make contact with each other, and just try to give yourself a little enough room to just kind of straight shot down to that little USB connector. And that's about it. That's all you need to do. You guys should be able to pull that off. Um, let's see, what are some other things I was gonna say? In the wiring video in episode 2, we talked about how some soldering is kind of necessary. If you guys don't want to solder, I mentioned try to find some male to female jumper wires, breadboard jumper wires. You can see I found these $7, 120 piece set. And they include male to female. You also get some male to males. They're pretty long size. What are they talking about down here? It told me the size, but these are pretty nice long ones too. So that might make it easier for you guys. Is that 8 inches long? It looks like it's claiming. Yeah, 8 inch. Each cable length is about 20 centimeter to 8 inch, and that's 120. So for all your project needs, you got female to female, male to female, and male to male. 120 piece set. It even says right here, mentions it's compatible with Arduino projects, breadboard, jumper ribbon cables. But that'll work, of course, for your Raspberry Pi, your Picos, all of the above. Let's see, on DigiKey. What's going on here? Click and hold. Oh, okay. We got to verify that we're not robots. They saw Servo Man. They saw Servo Man right here, and DigiKey thought we were a robot. So, show me the product. Here we go. So these are manufactured by SparkFun, but they're available here on DigiKey. And yeah, these are female to male breadboard jumper wires. These are 6-inch long, and it looks like it's a 20 piece. Got the part number right there, PRT 12794. I'm sure if you plugged in that part number, product number on the SparkFun website, I'm sure they probably got it there. If you want to buy it from DigiKey, that's cool. It looks like I found another one on Amazon, $6 for a 40 piece. These are shorter though. It looks like these are probably 4-inch long, 10 centimeter male to female. So if you're not interested in soldering, then you can find these male to female jumper wires so that you can connect your LEDs to the breadboard without having to solder. I thought I'd try to find that for you guys, try to make it as accessible as possible, no matter what your skill level is. It can be a lot, taking on the coding and the electronics, and now you got to learn how to solder. This project also, though, this project might be a great segue into learning how to solder, but then you do have to invest in your first soldering iron and etc., which I do recommend. If you guys are doing electronics projects, you're probably going to have to learn how to solder eventually. So it's 1, 2, 3, it's 5, right? No, it's 10. It would be 10 soldering connections, 2 per LED, if you went ahead and practiced soldering this up for your first time. If this was your first soldering project, maybe that's a good way to get started. I don't know. But if you're not ready for that yet, they got male to female breadboard jumper wires exist. So maybe make it easy for you guys. Let's see. I mentioned connecting to the Raspberry Pi Pico. Let's see what else. Back to the code. This is our loop, right? When I said, I think even in episode 1 and 2, I mentioned that Servo Man is just running on a loop right now. And what I mean by that is we got this pre-programmed sequence of movements and blinks and beeps. You know, this little instruction set that basically replays over and over again. And that's because this while true statement is creating a loop with a little microcontroller is going to repeat whatever instructions you give it. It's going to keep running. We're not using any if then, if else statements. We're not using any interrupt functions. This is a real simple, just a while true loop, and we're just turning off and on these LEDs. We're setting different values to the servos so they can move to different positions, and we're making the buzzer beep. Adding if then statements and adding interrupts was basically the direction we need to go to add more of a user interface, a UX, UI functions, try to make it interactive. Basically, if we want to push a button and make the arms move or see the eyes light up, then we would have to create like a wait command and an interrupt and then run the function of whatever we want that button press to equal a movement or a light up on Servo Man. And we'll get there. That's definitely in the works. That's definitely where we want to go with the Servo Man. But this is definitely step one. Honestly, when I originally built Servo Man, I was working with what I had and what I had on hand. I was building something from scratch with what I had on hand, and I wanted to code. I wanted to write some MicroPython code with what I knew, right? Like what I could kind of just pull out of my brain from scratch as a beginner. I wasn't following any tutorial. I wasn't listening to anybody tell me write this line of code and then write that line of code. So that's part of why he's so basic, because I am a beginner. So this is what I was able to pull off the top of my head from scratch with what I had on hand. In this video, I think this video 3, we're focusing on the code in this video, but I also want to just try to add as much information as I can, because this will probably be the final episode in this chapter. If you guys go to my Kofi page and you scroll down here, I have the diagrams up here for you. You guys can, of course, pause the YouTube video and probably figure out the wiring from there. You can screenshot it from there. If you want to download the images themselves, I have them here. You can cycle through them. I have 5 of the wiring slide images up here. Should be enough to figure everything out. Let's see. The only thing, I might have to add one more slide. We got the servo arms. I might not have put the slide that has the pin locations for the piezo buzzer. That's going to be our positive and our signal on pin 20 and our ground on 21, 22, 23, our ground on pin 23. So maybe I'll add that slide in there, but otherwise you should be able to figure out what you need with everything that I have up here. Also on the Kofi page, I posted, you can find the legs. There's a link right here to the Colts. If you guys have a 3D printer and you can 3D print Servo Man's legs, there's a little bit of an updated version. I just put Servo Man there. I also kind of shortened it and thinned it out so it's a little bit of a faster print and uses a little bit less material. It's still got the big chunky feet. The reason why I designed it like that was to just keep Servo Man stable so that it wouldn't be falling over on you. But so this is all available on the Colts and on my Kofi page. And then down here, the parts list. So I have up here everything you need, and I got links to everything. The Adafruit Parts Pal kit is kind of the key piece. $19.95 currently, and this kit comes with most everything you need. The LEDs are in there, the resistors are in there, the jumper wires, all the jumper wires are in there, and the breadboard, the half-size breadboard comes in this kit. I think that's kind of what I like most about this kit, is that it comes with that half-size breadboard. It really gets you started. This is a great beginner Parts Pal kit right here. I'm not sponsored by Adafruit. I wish. I wish. I love Adafruit as a company for makers and for electronics projects. They definitely have pretty much everything we need. Let's see. Can I go back? Okay. I'm also recommending this product right here. This is also another great way for $3 to power your Servo Man project. Nice little battery pack, and to really power any kind of breadboard project. That's what this is made for. And just remember, if you're going to use this product, there's no built-in circuit protection, and the batteries are in series. So it says down here, if you run rechargeables, using rechargeables will make this work nicely with nearly any 5-volt project. If you're running alkalines, non-rechargeable batteries, you're going to need something to drop the voltage down. So they're mentioning this other product here. But if you're running this with rechargeable batteries, that's simple and cheaper than what I'm using. I'm using the SparkFun power supply board kit, which is really cool. I'm using this, which is 12 bucks versus the $3 little battery pack. And I'm using another jumper wire cable. I'm using a battery jack to an XT60 cable, connector cable, and I'm using a LiPo battery. So believe me, that shoots the price way up there. I actually don't even recommend this anymore. I love this little board, and because this is stepping down our power to 5 volts or 3.3 volts, which either of those will work to power your Raspberry Pi Pico. Raspberry Pi Pico will work on anything all the way down to 1.8 volts, I'm told, all the way up to 5 volts. That's DC battery power. But really, you should be using 3.3 or 5. And when you have this board will protect your Pico. This is limiting the power supply going to your board from your battery. So that's what I'm using, and this is really cool. I plan on using this for other projects, not just for Servo Man, so that's why I went this route. But for anybody following along, definitely the this battery pack, this Adafruit battery pack, is cheaper and a little bit more straightforward if you're using rechargeables. Just that's the only thing. I don't want you guys to ruin your Pico or anything else. So make sure you're running rechargeables with this for AA. Trying to give you guys as much information as I can while keeping this entire video short and sweet. Trying to think of what else I was gonna say. I might go over, say a few more things about the code. Yeah, so we're not using any complicated statements. We're running off a loop. We're turning these individual LEDs off and on. Let's see, I might do something for you right now. I was talking about experimenting with different beeping sounds because it looks like where I'm just using the minimum value here. So I think I'm gonna edit this a little bit, try to get some different sound beep for you. Let's see, you should be watching that now. All right, so I paused the loop right now. I used the pause button on Sony. I'm coming down here and I'm just commenting out all of the commands related to the servo. And I'm doing this because I want to experiment with the beeper and I don't want to burn out the USB port on my computer while I'm plugged in to the USB, from the USB on the computer to the Pico. I mentioned this before, it's not a good idea to run servos when you're running off of USB computer power. It draws a good amount of current and you can possibly burn out your USB port. So this iBlink function, I'll let that run. I commented out that servo function, the other servo function, this one right here, I need to comment out as well. If you comment it out, then basically the code's gonna ignore it. MicroPython is not going to read any of the instructions that start with a hashtag number sign. So there we go. I just strictly want to work with the LEDs and the buzzer. Okay, there we go. You guys see that? And then I want to go down here. Let's go ahead. Let's run this. Let's press stop again. Kind of refresh, and then we'll press run. So now we just have the eyes. And that's it. The servo's reset to the first position and they shouldn't move again. We're just running the blink, the talking. We should have the left eye blink, the mouth, the double blink, and that's it. Okay. So now let's pause and I want to change. So we have a min. Let's go max. Or let's go mid. And then, I should pause and then we'll go max. Min, off, mid, off, max, right? Okay. And then we should go back to min. So let's refresh and then let's run. Let's see if we get a different sound. I didn't hear a different sound. I heard almost like a click click. I don't know if that was it. Oh, there's a little bit of a different tone there. I don't think max works. Okay. I think it's not reading the max. I think it is reading the mid. Okay, so let's go back over here. Let's go min and so we have min, mid, min. Let's go mid, mid. Well, that's pretty cool. I like that. You can barely tell, but there is a difference in the tone. Let's see. So it's not reading max, huh? I wonder what we could do there. I'm gonna pause it. And min and mid. I wonder what's the highest tone we can run on our piezo buzzer. It's running the 10 million and the 15 million. I'm gonna call it. All right, 1, 2, 3, 1, 2, 3, 4, 5, 6. It's running the million and the 1,500,000. Let's see if we could define another one. I don't know what should we name it. Let's name it. I don't know. I'm just gonna name it high equal to. It doesn't want to read max, but let's try 180. 1, 2, 3, and another one. There we go. And then let's go back down. Let's call that value. Let's see. Let's see if we get anything. Oh yeah, we get a higher tone, a lower tone, a different tone. We do get a different tone with different values. So that's one thing you guys can experiment with. It sounds like with the higher the value, it actually gets lower. Yeah, it's almost like a complete. It's almost like even a lower volume. With a higher pulse width modulation value. So let's go with let's go low equals I wonder, so what can we do here? Can I go 0, 5? Is that a thing? I don't know if this will work. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. 6. No. -1. We'll see if that gives us an even higher pitch. Lower value, higher pitch. So let's come over here. Let's create LO. I don't know why I'm running the off. Let's go low. Maybe. We'll have to experiment with that. I wonder if I can almost get the piezo buzzer to play a little tune. I don't know. You don't really get a different pitch. It's just almost a little bit of a lower volume. But you can experiment more with that, more with the noise. That's pretty cool. So I just wanted to show that we got some kind of a result. I don't know if you guys can really hear the difference, but it is, it seems like just a lower tone or a higher tone, but it seems like two versions of the same tone. It does almost get quieter. Cool.